Hello, everybody. We will be continuing our investigation of mixed circuits, basically from where we left off last time, and trying to figure out currents and voltages on all the resistors in the circuit, but we're going to be doing it slightly different this time. You will not be given the voltage of the source. You will instead be required to apply the concepts you know and being able to identify series and parallel. So I've already got these written here. You may want to pause the video at some point. But in series, you have to know that the current is the same for resistors that are in series. You should also know that the voltages in series add together. In parallel, you have to know the voltages are the same, and it's the currents that you can add together. Now, another thing that we didn't focus on a lot when we were previously doing mixed circuits is that the voltages in a loop add to the voltage of the source. So what I mean by that is, let's say, for example, we always start at the battery, and we'll go through resistor 1, through resistor 2, and back to the battery. What that means is that the voltage of resistor 1 plus the voltage of resistor 2 should add up to the voltage of the source. Another loop, choose any loop. Let's go with green one here. We'll go from the battery, we go through R1, we go up through R3, down through R5, and then we head right back to the battery. What that means is that the voltage on resistor 1 plus the voltage of resistor 3 and the voltage of resistor 5 should add up to the voltage of the source. We could do another loop if we needed to. So let's go with this color. We'll go through R1, through R4, through R5, and back to the source. What that means is that the voltage on resistor 1 plus the voltage on resistor 4 plus the voltage on resistor 5 should add up to the source. It's a really good way to check your work and make sure everything makes sense. It's also a really good way to find the voltage of the source. If you don't know what it is, but you know the resistor values, you can quickly find the voltage of the source. So what we're going to do now is do a few quick, easy examples to try and help you on your way. So here's a really simple circuit with only 3 resistors. And the problem may start by saying that they give you the current on one of the resistors. So we'll give you the current on the 5 ohm resistor and simply say that it is 4 amps. Okay. So what can we do with that? That's the only information we have. We have 3 resistors and we know the current on one of the resistors. Well, if we have I and R, we can quickly get the voltage. So that's just V equals IR, and we get 20 volts. What you should realize is that the 5 and the 10 are in parallel. And in parallel, voltage is the same. So if the voltage on the 5 is 20, then the voltage on the 20 will be 20. Now that we know V and we know R, we can get the current going through that resistor. That's just V equals IR, or 1 amp. So already we found out a couple things without knowing the voltage of the source. What you should also realize is that the current that flows through the 10 is then split. Some of it goes through the 20, some of it goes through the 5. Remember that in parallel, you can add the currents together to get what came into that junction. So the current that came in here at this junction split into 4 amps and 1 amp. Hey, that's a total of 5 amps. Tough math, right? That means that there must have been 5 amps flowing through the 10 ohm resistor before it reached the junction. If we know the current and the resistance, we can quickly find the voltage, which would simply be 50 volts. Okay. What you should also see is that the 10 ohm resistor gets all the current, which means the current coming out of the source must have been 5 amps as well. And we could also get the voltage of the source. Remember, it was suggested that you just draw a loop. So I'll draw a loop. I'll go through the 10 ohm, the 5 ohm, and get back. If I add those voltages together, Basically, the voltage of the source would then be 50 volts plus 20 volts, which gives me 70 volts. If I wanted to double check the work, I could choose a different loop. I can go through the 10 and the 20 and get back. That would be, again, 50 volts plus 20 volts gives me 70 volts. So I'm checking that work to make sure that everything is consistent. So you notice we didn't really collapse the circuit down. We just kind of used our understanding of series and parallel to figure out everything else. So let's try a different example. So here we have another simple example. We only have 3 resistors, and let's say that in this case they give you a voltage to start, maybe 30 volts on the 10 ohm resistor. That's all you're given, and you got your 3 resistors. So right away you should be able to see that you have V and R. You could simply get I, which is 3 amps. You should also see that the 10 and the 6 are in series with each other, and in series current is the same. So don't overthink this. There should be 3 amps on the 6 ohm resistor. Now that we have I and R for the 6 ohm resistor, we can quickly get the voltage, which would be 18 volts. Another concept in series, other than the current being the same, is that you can add the voltages together. So if I add these together, I'm going to get 48 volts. You should be also aware that this area here, the 10 and the 6, are in parallel with the 8. And in parallel, voltage is the same. So if this area up here has a total voltage of 48, then the voltage down here on the 8 ohm resistor is simply 48 volts. Now that we know V and we know R, we can get the current, which would be 6 amps. So now we know that there are 6 amps flowing this way and 3 amps flowing up here, and they reach this junction. That must mean that in parallel we can add the currents together. So that must mean that there is 9 amps flowing out of the source. So now that we know that, we can try to find out the voltage of that source. This is kind of a really ridiculously easy example. Draw a loop. One of your loops can go through the 8 and back, which I'm sorry to say is just the voltage of the source is 48 volts. That's pretty straightforward. And another option would be to go up and around. So we go through the 10 and the 6 and get back. In that case, we would be doing 30 volts plus 18 volts. And that would be 48 volts. So again, that helps to prove that what we're doing is correct. That's 48 volts. In the homework, it's going to ask for the total resistance of the circuit. If you want, you could break it down. If you really wanted to, you could collapse the circuit down and figure it out. But you also know that the voltage of the source equals the current coming from the source times the total resistance of the circuit, the REQ. So REQ is simply voltage of the source over current coming out of the source, which is 48 volts over 9 amps, which equals what? 5.3 repeating? I hope that's right because I don't have a calculator in front of me. Ohms. So it's going to ask you to fill in a chart at some point, and it's going to want to know the total resistance. In my opinion, that's the easiest way to do it. Now, you should know that both of these examples were pretty simple compared to the homework. One may be very similar, but one is going to challenge you a little bit. So I want to see how well you do with that. Other than that, I hope all is well, and you all take care of yourselves.